All right. Okay. Hi guys, welcome to 4-H in the Field. This is our last 4-H in the Field. If you've attended other workshops, you know how this goes. If this is your first, we ask that you just chat in the box if you have a question, or if you do want to ask them out loud, just be respectful of others and mute yourself if you're not speaking. I will be sending out a survey probably tomorrow so that you guys can all give feedback on how you liked this kind of presentation and if you want to do more of this stuff in the future, barring COVID is not a thing. So anyway, we are going to just let our guests introduce ourselves so you guys can work out how you want to do it, and we'll go from there.
Okay. Hi, I am Claire Meshkat, and I am an aerospace engineer. I started out working at Boeing Commercial Airlines, so I worked on the big jumbo jets that you would usually take when you go on a big trip across the country or even overseas. And then I worked as an engineer for Boeing Space Exploration on the Space Shuttle program. So I worked with NASA, and I got to meet a lot of astronauts and figure out how rockets launch, just like the rocket that was supposed to launch with SpaceX yesterday, that we'll get to see hopefully on Saturday. And then most recently, I worked at a company called Air Tractor, that is the world's leading manufacturer of agricultural airplanes. That is crop dusters, like Dusty Crop Hopper, if you've seen that Disney movie Planes. That was actually drawn off of one of the airplanes that I created. So I've done a lot of things with aerospace engineering, and now I get to make lessons and fun activities for kids like you to do to learn about engineering.
I like our thumbs up from Kate on that. Hey guys, I'm Natasha. So Claire and I actually met as roommates and classmates in aerospace engineering at a school called Texas A&M University. So we're both located in Texas. She's more on the north side, right near Dallas in a rural area, and I'm near Houston. So just so you know where we're located. So I'm also an aerospace engineer, and after graduating, I went and worked for the Department of Defense. And so we saw, Alicia, your flyer and about satellites. And so that would be me. So if you guys had questions about satellites, that's one of the projects that I worked on in the Navy. I was actually responsible for helping figure out what kind of frequency the satellite operates. So if you know anything about satellites, it's similar to like your radio station. You have different frequencies, like you're listening to 90.9 or 102.7. I don't know the stations y'all have in Utah. And so satellites are the same way. They have different frequencies they operate on. And so I had to make sure the satellite we were sending with the Navy was on a different channel than any other satellite. And so that got sent to the International Space Station, which is where those astronauts that Claire was talking about are going to be going on Saturday. And so we sent the satellite, and then it was launched from that big satellite, the ISS, and it orbited the Earth and did a bunch of measurements of atmospheric data. So that's a little bit of what I did. And now I'm also a STEM educator. So I run an after-school space club program. So I work with kids just like you guys, and we do launch rockets. We do all sorts of really fun space activities. So we're happy to answer any questions you have about space and aerospace and engineering, whatever you're interested in.
Awesome. Okay. Why don't you guys take turns answering? Just maybe explain a little bit about like what your day-to-day job looks like.
Well, I mean, now it looks a lot different because now I'm in the education realm, as is Natasha. So, but we probably should speak more on engineering because that's what you'd be most interested in hearing, because I hope you guys have thought, at least considered, engineering as a career. That's not something that was talked about a lot when I was a kid. So as an engineer, you usually have a very specific role. So we are aerospace engineers. And so that means we typically work with airplanes or satellites or rockets. And so we work with things that fly. So we have different things that we need to do to prepare things to fly. So we do a lot of computer simulation and a lot of analyses to figure out, is a rocket going to explode? Hopefully not, but you don't really test, is it going to explode, until after you've run some simulations and figured out how all the parts are going to fit together. So you usually work in a team. So an engineer is not a solo sport. So if you don't like people, you really aren't going to do well in engineering, although there are a lot of engineers that don't talk very much. But you work in a team, and your team of engineers have to solve a lot of problems. And we like to go through different tests and figure out how we're going to accomplish whatever the problem is that we're going to solve. So projects are like year-long or even decades long, and working towards an end goal like launching a rocket. The SpaceX rocket took about 9 years to figure out how they're going to build the Falcon 9 and make it fly, and especially to put humans on it. So long-term projects and problem solving is, I guess, what most of our days are filled with.
Yeah, and so when I was working for the Navy on that satellite project I mentioned, there was probably a couple hundred people that were behind that project. So I was just one of many engineers and scientists. And so I had a lot of meetings. I talked to a lot of people on the phone, was a big part of my day. But then I also got to go to the lab and do some experiments. So it's a mix of the simulations that Claire's talking about. So you're on your computer. Programming is an important skill for an engineer. We did a lot of mathematical analysis. So math and science, you definitely need that as an engineer. But then communication skills. That's something that we don't talk a lot about, is how to talk, how to communicate your ideas. So if you've ever done an engineering design challenge, a STEM challenge, you know that you could have the best idea in your head, but if you can't communicate that idea, how to solve a problem, what your design is, no one's ever going to build it because they don't know how to do it. It's in your head. And so figuring out a way to get that idea out is a big part of my job when I was working as an engineer, is just sharing ideas, communicating, and working as a team.
That's awesome. Kay, we have a question from somebody who appears as Beck S. They want to know, do you use a lot of math in your head, or do you use it on a computer or a calculator?
Great question. So I don't trust the math that I do in my head. So I try to do it in my head first if I need a quick calculation. But as an engineer, it's really important that you get the numbers right. And so I definitely use a calculator.
Yeah, so when you go to college, if you're going to study engineering, you get to use calculators and software to do the math. So you're never expected to do all this complicated math in your head. So don't worry about that. If that's not your strength, that's definitely not mine. I'm all about the calculator and using that. So yes, you get to use different tools to help you out. But the important thing is using common sense, because if you plug in the wrong numbers in the calculator, it's not going to tell you they're wrong, right? You have to know that. And you have to know that that final number, if it's off by like a factor of 1,000,000, you're like, wait, something doesn't seem right. So it's still important to be thinking as you're calculating.
And another important thing, what you're talking about, Natasha, is units. Like, I know that doesn't have to do with calculating in your head or using a calculator, but units are so important. And I wish that they would have shared more examples of why it's so important when I was in school. But there was one example with NASA that they had a satellite that they worked with jointly with the Russians on. And so here in the US, we use a lot of like inches and feet. Well, over in Russia, they would use the metric system. So, but they were using the same numbers, but they didn't communicate what units they were using. And so they had a big, really expensive satellite that crashed because of units. They used the right numbers, but wrong units. So that's really important too.
I love that. Okay, do we have any other questions? I have a list, but I want to see if you guys have questions. We'll just think for a sec. Okay, they want to know, how many years did you go to school?
Ooh, we both went to college for 4.5 years. We wanted an extra football season in college, right? As an engineer, it's actually the only professional degree that I know of, Natasha may correct me, that only requires 4 years of school. So like if you become a doctor or like a dentist or an optometrist, that requires typically around 8 years of school just to become that professional, but an engineer only requires 4. So it's a lot of school to cram into 4 years, but it's a great program.
So you guys are both Aggies, right?
We are.
So the university that's here in Logan, where we're from, we're Utah State. So we are also Aggies.
Oh, okay.
Yeah. Anyway, okay. So can you tell us, do you need a lot of computer skills?
Ooh, yes. You need a lot of computer skills. So, which I think most of kids these days are on the computer a lot. It was kind of new when I was growing up. That might date me a little bit, but computer programming is a great thing to have because you can use it in most engineering degrees. In aerospace, definitely. That's what my job was when I worked for NASA. Is my job was a programmer to take the data that we needed about the weather and like what was going on with the SpaceX launch yesterday was something that my job was, is to figure out, okay, if we're having a lot of wind this way, we need to tell the rocket to go this way to make sure that it's going to meet the trajectory that it needed. So I'd have to program what the trajectory of the rocket would be in a computer programming language. So knowing how to code is really important and gives you a leg up on a lot of different things that you can do with engineering as well as a lot of other careers.
And some of the other more basic computer skills like Excel, I use that with the Navy to do a lot of calculations. So I don't know if you guys use Excel or Google Sheets in the classroom. That's a good skill to have that we actually use in the real world. Google Docs or Word documents, PowerPoint presentations, again, communicating your ideas. Those are all really important that engineers use every day.
That's awesome. Okay, so tell us, Beck, you're the greatest. She wants to know, or he wants to know, did you work on top secret projects?
Well, if we told you, we'd have to. I'm just kidding. Yes. I guess we did. Most of the top secret projects that you work on in engineering have to do with 2 things. Either it has to be a proprietary, which means that you don't want other governments stealing the information, or you don't want other companies stealing the information and trying to create whatever it is you're creating first. Or it could be something that there's something that's dangerous that you don't want to get into the other people's hands that might misuse it. So we had those kind of projects. Rockets are definitely fall in one of those things because those can be used in military applications that we don't really want to be in the hands of some countries. So definitely worked on some of those projects. We even did that in college. We weren't allowed to put our rocket projects because Natasha and I were on a rocketry team in college. That was our final project, was to build and launch a rocket that was about 6 feet tall. And we weren't allowed to put any of our data on the internet because they were worried that people might steal it and use it as a weapon. So those are the kind of top secret projects I did. But Natasha worked with the government, so I'm sure there's stuff there too.
Yeah, so in order to get my job, I actually had to pass a background check. So I had the secret clearance. And so whenever I would go on trips, so the really cool part of my job was I got to travel all over the country. And so I got to go to Hawaii and DC and all sorts of places. My favorite was Hawaii though, because you could have some extra vacation days on the beach. But I couldn't tell people that I was there because of my job. And so I have to have this whole backstory of, I'm just going to visit some relatives, because it was very suspicious if you're saying I'm here on a, mission with the Navy. And so there was a lot of things that I couldn't really talk about, like just even to my own family, because it was considered classified. And so the downside if you're working classified is you had to be in a building with no windows. So we would actually leave our phone and personal items outside in our car. We could not bring our phone. We couldn't bring any like Apple Watches or anything fancy because you might take a picture if you're a spy, right? They want to avoid any of that. And so you go into basically this closet that's literally a safe. Like you have a whole keypad to get in and a whole safe. You had to have an ID at all times. And then you had this classified computer that was only connected to other computers on a classified network. So any emails that you're sending are only going out. So like I couldn't send, Claire an email if she wasn't part of my job. And then there were certain things that we were told, like, you can't talk about this. And we'd have trainings all the time to make sure we weren't leaking, any information by accident. Because most of the information that's classified, you don't even think about. You're like, oh, no one's going to care about that. But someone might be able to piece it all together, like Claire is saying, and build a rocket for maybe not the right reason. And so working with the Navy, with the satellites, a lot of those were military satellites. And so we didn't want to let other countries know the frequencies that you're operating that satellite on. So it was a pretty interesting world to be in this like secret classified space.
That's awesome. So tell us what happened yesterday. I don't know how many of the kids that were on yesterday were watching the launch. I was definitely watching it and was kind of bummed by, T18, whatever, that they shut it down. But so tell us what happened. What happened?
Well, so a lot goes into a rocket launch, and there's a couple things that dictate what the launch window is. Because I know our time, it was 3:33 was when it was supposed to launch, which seems like a really random number. And they don't just pick a random number. It has to do with the location of where the rocket is launching from, and then where it's going to. And so they have to make sure that those things line up, because, say that the Earth is always rotating, right? If your rocket is launching from here and you need it to get to something that's on the other side, that takes a lot more fuel and a lot of time. And there's a lot that goes into how you're trying to support your crew while they're aboard the rocket during that time. So it'd be better if you launched it where it's closer to the place that you're getting to. So they have to make sure that all the things that are spinning are lining up perfectly. And then the other thing is weather, which is why they scrubbed the mission 16 minutes before. And it's not just the weather right where the rocket is launching. It also has to do with the weather where the rocket would abort. So let's say something went wrong after the rocket launched and they need to abort the mission. Well, if it lands somewhere in the ocean where it's really rough and the crews can't get there to rescue the astronauts, that would be bad too. So they're monitoring the weather all over and making sure that there's perfect conditions, and that just didn't happen yesterday, and that's why they scrubbed it. It had more to do with the weather in the abort locations than in Florida where they were launching.
And Claire, can you talk about why this was such a historic launch, or will be on Saturday?
Yeah. So there's a couple things that make this launch so incredible and so important for our history. One is that we have been hitching rides with a Russian Soyuz rocket to send our astronauts into space to the International Space Station since 2011. That was the last space shuttle launch, and the space shuttle was built for a certain purpose. If you've ever seen the space shuttle, I think I have one. Hold on. I have a piggy bank shuttle here. So this is a space shuttle, and you can see that it has this really big compartment on the back that can fit a school bus inside of it. That's how big it is. And it was meant to build the International Space Station. So all the different pieces of the International Space Station would fit inside this compartment in the space shuttle. Well, that's a lot of wasted space if we're no longer building it. And that's why they retired the space shuttle in 2011 after the last launch. And so since then, we've only needed to send up small bits of cargo and astronauts up to the space station, which we've always had astronauts up in the space station for the last 20 years. We've always had people up in space. And so we send astronauts over to Russia, and they launch from Russia. So we really wanted to have astronauts launch from American soil again. And so that's what this launch was about, is we will finally have the capability to launch astronauts from US soil. So that's the first historic part of this launch. The second one is that NASA isn't the one that's sending them up there primarily. They contracted out SpaceX to send up these astronauts. So it's the first time that a private company is being paid by NASA to launch up astronauts. So that opens up a lot more capabilities because private companies can raise their own money instead of just relying on taxpayer dollars. So this is really huge for both of those reasons.
That is super cool. Okay, do you guys have any more questions that you want to ask today? Okay, while they're thinking, and Natasha, why don't you tell us a little bit about what kids can do at this age if they're interested in a job like what you do?
Ooh, that's a good one. So I did not always know I wanted to be an engineer. I think Claire, you always wanted to be an astronaut, right? And so you just had this like mission plan.
Still do.
She still does. But from a young age, you were kind of preparing, right? I would say if you are interested at all in engineering, we talked a lot about math and science. So taking as many math and science and computer programming classes that you can as soon as possible. And I know there's a lot of schools that offer after school robotics clubs, and I'm sure, you guys offer different STEM programs. Get involved now. If you're in elementary school, if you're in middle school, now's the age to do it, because that will get you ahead of everybody else. Because the more experience, the more exposure you have to that, the better off you'll be. And don't be intimidated to talk to engineers like us, right? We love talking to kids. So if you have a question, just email them. Like find if there's say you want to be an aerospace engineer, look up a company that's nearby and just send them an email and be like, hey, I'm so-and-so. I'd love to hear more. Can you even give me a tour? Maybe after the COVID. But we would be happy, to show you around, and just don't be intimidated. And Claire, actually, you have a story about being intimidated and how you wish you had reached out.
Yeah, I got, when I guess I was about 10, I got the email address and phone number of an astronaut that I followed, and I never reached out to her. I was just so scared to reach out to an astronaut because I was like, oh, it's an astronaut. They know everything, and I'm just, a kid, and I don't even know what questions to ask or how to talk to her. And I've missed a huge opportunity because I could have reached out to her and just said, hey, I want to be an astronaut. How do I do that? What classes should I take? What should I look for? What should I be good at? And, I'm sure there could have been a lot more to that would have helped me. So reiterating what Natasha said, don't be afraid to ask. There are no dumb questions, right? So great questions that were asked today, perfect. Ask what you need to know. If you're intimidated because you don't think you're the best at math or science, we aren't. But that's why you ask questions and try your best in school. Get help from your teachers. Reach out to even colleges. If you want to be an Aggie in Utah, reach out to colleges, and they probably have summer camps. I think, especially if you're interested in engineering, it's as much about figuring out what you want to do as it is figuring out what you don't want to do. So I think the more exposure you have, because you may, I did some research when I was in college and realized that I didn't want to work in a lab. That wasn't for me, even though I thought I did at the time. So just try things. Go to camps and say, oh, I really think I want to learn about space. Well, maybe you do. And maybe you find out it's not for you and you gain an interest in something else that's incredible. There's 100 different types of engineers? I don't even know. Aerospace is just one of them. So you just figure out what you want to do by asking lots of questions and talking to people.
Okay, so we have two. These are going to be our last two questions. So somebody who appears as Larson says, do you have a specific math equation that you use daily? So we'll start with that one, and then we'll go to the next one.
Well, not right now, but I will say, so I am married to a mechanical engineering professor. So he teaches engineering students. So if you were to go to college, in Aggie land here, you might be your professor. And so kind of like the equation that everything goes back to is F equals ma. Y'all have heard of Newton's laws? That's like the foundational physics equation that we heard over and over and over again in engineering school. And it gets a lot more complicated from there, but that's like the base equation. So F equals ma will solve a lot of problems.
Yeah, that's what I would say too. It's all about figuring out what forces are and where they are.
So it looks like this, right? F equals, I'm going to type it, ma.
You got it.
Okay.
So M stands for mass and A stands for acceleration.
There you go.
So your acceleration right now actually is gravity. So, and then your mass is your weight. So there is a force of gravity on you right now.
That is definitely, I didn't take physics. I am design and creativity and art. That is my thing. So I'm like, good for you guys. Okay. And then Bex wants to know, did you need to know chemistry?
Yes, we did need to know chemistry. And that depends on what you do in your job. So I needed to know chemistry in a couple of scenarios. One was on rockets to know what kind of fuel to use. And then in my latest job as an agricultural airplane manufacturing engineer, the crop dusters spray lots of chemicals. And so we had to figure out what those chemicals would do to the different parts of the airplanes. So for example, we had our crop dusters that we made were had a tail wheel. And so when they would spray things out of the booms, that spray chemical would get on the tail wheel, and we had a couple wheels that just melted, like completely disintegrated. And so I needed to know some chemistry to know, well, why is that happening? Like, what eats aluminum? So you can't, it just depends on your application. We had to take one class in college on chemistry. I love chemistry, so it was fun for me, but a lot of my engineering peers hated it. And so, you know, it's okay if you don't love everything. Because there's also textbooks in the internet if you ever need to look something up later.
And that's important because what you learn in engineering school is how to think and how to problem solve. There's no way they can teach you every equation, everything you're going to need to know. And so I was doing a lot of researching on like, how do I solve this problem? Or like Claire's saying, we only had one chemistry class, but she still had to know chemistry. And so she had to go find a textbook and learn it on the job. And that you're just going to have to do that. And that's any job. Whether you're wanting to do like journalism or design or architecture or whatever, you're going to be learning on the job. And the point of school right now and college is to prepare you on some basics and then just how to think, critically think, problem solve, be creative. That's the most important part.
Oh, that was perfect. Okay, awesome. Well, we are, I was not ending that very well. We're gonna be done, but thank you so much. Okay, as you guys leave, make sure you just unmute so they can hear you say thank you. This was our last one of this series, and hopefully we have updates if we can have 4-H in June soon. So anyway, as you guys exit, make sure you unmute and say thank you.
Thank you.
Thank you.
Thank you. Thank you.
Y'all enjoy your day.
Thank you.
Bye.
Thank you.
Thank you. Thank you.
Bye.